Anyway, while we're loading this, I'll just introduce. So last year at the workshop, I introduced the North American Land Data Assimilation System, Phase 3, that NASA is developing, a multi-NASA center effort. And so I'm going to start the talk off a little bit differently by showing a demo of a Microsoft Copilot capability that we're using LLM capabilities to be able to query just with a language question query, and then it will interact directly with the database that we're developing. So here's the outline of the talk. So we're talking about a North America scale 1 kilometer resolution land surface modeling data set that we're developing here at NASA. So I'm going to show you a demo of this LLM interaction that Maya Hashima, our team member, has worked up. And then after that, we're going to talk about stakeholder engagement. That's at the crux of our NLDAS-3 development effort, is to make sure that we're developing applications and tools that are directly beneficial to stakeholders that can use our land modeling data sets. And then we'll get into a few specific examples, and then we'll talk about how we can offer up NLDAS-3 for the community out here. So let's hope this video works here. So credit to Mahia Hashima. I'm not sure if I pronounced that right. Hashemi. Okay, there we go. So the first question she asked Microsoft Copilot, or Hydrology Copilot, I should say, is show me the soil moisture over the Southern Plains in August 2011. And that was a big drought year in the Southern Plains. So Copilot is querying the NLDAS-3 database, and in 41 seconds, it pops up an answer. And the way she tailored the interaction with NLDAS-3, this is like a Google Maps pan and zoom capability. So it's loading up the tiles of the volumetric soil moisture of NLDAS-3. She zooms into Texas. And then we ask the next question is, oh, one thing I should say is that you can access the Python code that generated this image with the data. So you could use the Python code and customize it for yourself. So the next query is, show me the difference between August 2011 and August 2007 soil moisture. 2007 was a very wet year, so 2011 minus 2007 results in that dry difference there that you saw. And then the third query is, show me the root zone soil moisture time series for 2011 over the Southern Plains. So now we're going to look at a time series graph of the monthly average soil moisture values over that Southern Plains subset. And so Copilot moves through there, and in 50 seconds, you get a time series graph during 2011. It's showing you statistics of the mean, the min, and the max volumetric soil moisture. And now the final query is the total column 0 to 200 centimeter soil moisture percentiles for a specific day, August 2nd, 2011, over that same Southern Plains region. And this took a little longer because it had to build a climatology, so it was about 3 minutes. We're going to probably pre-compute the climatology to decrease that time frame. But again, you get statistics, and it spits out the percentage of aerial coverage of all the drought categories, D0 to D4. And then you get the percentile map that loads up. So that gives you a flavor of the type of interactability that we're looking to develop with NLDAS-3 and using AI, just large language model queries. So now we'll get to the standard part of the talk. And so at the crux, like I said, of NLDAS-3 development is stakeholder engagement and co-development. And so Kim Locke and Ryan Wade in the audience here, they are heading up our initiatives to engage with the stakeholder community to make sure that applications can be developed that meet the needs of the community. And there's a large database of users with phase 2 of NLDAS that are currently using that product for their applications. And so we're looking to co-develop with them and lead to improvements in their applications and to develop new applications that can benefit from 1 kilometer resolution land model data over all of North America. So what do the stakeholders need? This is a small list of some of the key applications that the community, the end user community needs. And so part of that is what we are coining it Nifty 50. We're reaching out to the entire 50 states, and it's actually Nifty 50 plus because we're reaching out to territories and tribal nations as well. And we only have a few states left to reach out to in the light blue, and we have active co-development in the states in the green. So this is exciting that we're getting close to reaching out to every state in the country to plant that seed of what NLDAS-3 might be able to do for you and how we can co-develop with them. So at the crux of NLDAS-3 is the NASA Land Information System, and we have been developing blended meteorological outputs, gridded outputs at 1 kilometer resolution over all of North America, hourly cadence over the entire period of record. And we are assimilating remote sensing data, soil moisture. We have an AI-informed snow water equivalent product that we're assimilating. We have terrestrial water from GRACE. We have vegetation from MODIS, leaf area index. That's all being assimilated into the land model to produce high resolution outputs of water, energy, and carbon fluxes over this entire North America domain. And then providing real-time cloud-based outputs and co-developed applications and interactive applications that can more easily benefit the end user community. So NLDAS-3 will provide consistent near real-time meteorological forcing data for drought and water resource monitoring. Our period of record is 2001 to present, and we currently have these core meteorological input data sets. That's what drives the land model, and these are at hourly frequency from 2001 to present. And so these key hourly inputs then drive the land model integration and data assimilation, which also spans 2001 to present and gives you these key output variables of temperature and water in the soils, snow, vegetation and carbon, energy, hydrology, and also derived core quantities such as climatologies, anomalies, and percentiles. So now we're starting to examine the data, make sure that we have a sanity check. It looks appropriate compared to metrics like US Drought Monitor. And so here's the 2012 Midwest and Great Plains drought. And so here in the right panel, we're looking at the standardized precipitation index coming from those forcing variables of NLDAS-3. And you can see it's representing this large drought footprint broadly and accurately compared to the US Drought Monitor. What does the data assimilation of vegetation look like? So here's a neat case study that we put together from, we know that vegetation responds differently according to different weather and climate anomalies and features that are non-standard. Normally, vegetation is handled in a monthly climatological input that's static in land models. Well, we know that's not necessarily the same year from year, year by year, because we have anomalies such as drought, and in this case, a hard freeze happened after an early green up. So in March of 2007, we had very warm early spring conditions, and the deciduous trees all came out early in the deep south of the US. And then in Easter weekend, the second weekend in April, a hard freeze hit, wiped out the deciduous trees in the southeast. They all had to restart a few weeks later. So this is the assimilation of leaf area index into NLDAS-3. And in a 2-week difference, this difference panel shows up in the right-hand panel. And you can see that those oranges and browns show that broad decline that the model is representing. That's going to adjust the energy fluxes, which affects the draw out of water in the soils. So that's going to give you better soil profile states. So assimilating vegetation, especially in those transition seasons, is going to be a key improvement in NLDAS-3 modeling. Shameless plug for a project that we had selected. This is a NASA Water Resources Applications project, where in the Southeast Dews region of NIDAS, we're going to be looking at soil moisture volatility indices to try to get a better lead time on rapid soil moisture declines that lead to flash drought events. And then we're also going to look at AI-trained basins to look at low flow predictions and link those two to the soil moisture volatility and the rapid decline in soil moisture, linking that to low flow impacts, and find the time lags between rapid soil moisture declines and low flow hydrology. So that's going to be an exciting project we're going to look at over the next 3 years. And here's the last impact example. This is, of course, Hurricane Helene that impacted the Carolinas and particularly Asheville hard. This is an example from the sport list where we're looking at hourly MRMS precip contours and the percent soil saturation in the Western Carolinas and Georgia and South Carolina. And this is before and after soil moisture percentile relative to climatology. And oftentimes you see tropical cyclones or atmospheric river events that lead to that whiplash effect, where you go from either normal or anomalously dry to extreme wet and flooding conditions. And you can see over the Carolinas, we're up near the 100th percentile in soil moisture over almost the entire region. So NLDAS-3 timeline availability. We have completed the beta version of the surface meteorology. That's the hourly analyses from 2001 to present. We completed our open loop run. That's the simulation over the period of record without data assimilation. You need that background integration as a background field before you can do the data assimilation. And we are currently running our final data assimilation with all those variables, remote sensing data sets being assimilated. And later 2026, we expect to see those final data assimilation outputs become available. And later this year and next year, an ensemble forecast capability. So I'd like to leave you with this. We have user engagements and points of contact. I ask you to see Kim Locke. She's at the front table here, and Ryan Wade. It should be in the back. They are our key focal points for user engagement and co-development. So will NLDAS-3's improved capabilities help address some of your priority needs? Are there downstream or value-added products that you would like to co-develop with us? And would you like to be an early adopter and a tester of NLDAS-3? So come see us and we'll gladly sign you up to co-develop. And with that, I'll take any questions.
All right, we'll start with one in the room. I see Zach has his hand right away.
Hey, thanks for that talk.
Thanks, Zach.
2 super quick questions, maybe not super quick, but first off, I saw a lot of qualitative evaluation of the data. Can you talk a little bit about how you're validating the data quantitatively, especially the precip forcings and other things like that? And second, are you using, can you talk a little bit about your assimilation techniques? Are you using ensemble calming filters, and are you doing parameters with the state variables?
Yep, the first question. Yeah, I'll repeat the question. So it was a 2-phase, fully loaded set of questions. Thank you, Zach. So at a high level, yes, we do plan to compare against in situ observations. The question was about validating quantitatively the land models and the forcing data sets. So yes, in fact, I think we have an inner comparison with one of our co-developers where they're comparing the precip forcing data sets to other QPE data sets like MRMS, stage 4 and such, AHAB. So that's one active area to validate. And of course, we can validate the final soil moisture analyses against the National Soil Moisture Monitoring Networks. That would be one good way to validate the data set. The second question was the data assimilation. So at the core of the NASA Land Information System is an ensemble common filter, like you said. And so there's background error covariances and observation error estimates, and those are blended with that ensemble common filter algorithm. And that's what produces that final analysis data assimilation result.
Cool. So it's just on the state variables. You're just doing
The-
grade data correction.
I believe so. I could check for sure with the list team at Goddard.
We have nothing online, so we do have time for one more in-room question if anyone else